Hello, Harishma. Hello, my warriors. Vanakkam, namaskar, sat sri akal, hola, bonjour, marhaba, hi, Akai. Hello, Vishwanath. Welcome to the marathon session for your physics term 2 examination. And if you have not watched my previous strategy video of how to get 35 out of 35 marks, how to score maximum in your term 2 examination, I urge you to watch that session as soon as possible after this session is over. Okay, it's there on this channel, Vedantu Enlite, the dedicated English medium channel for all the competitive exams that you guys are going to write. Hello, my lovely warriors. And in today's session, what are we going to do? We are going to complete electromagnetic waves, ray optics, as well as optical instruments along with wave optics, and I'm going to give you all the important conceptual pointers along with some questions. Now these questions can be a collection of questions from previous years or NCRT or exemplar or my own question bank. These questions will help you build up and gain confidence in all the 3 chapters. Tomorrow we are going to do the modern physics part. How many of you have seen the semiconductor sessions? Good evening, Kritika. Hello, Sandeep. This session will go all around for like say 2 hours, maybe 1.5 or 2. Yes. Yeah. Deleted syllabus will not be taught because we are focusing on boards. So please make sure that you realize that this session is for the term 2 board examination. Already watched Mr. Unpredictable. Alexander, you can watch it right over here. And by the way, my name is Shreyas. I am the physics master teacher, training, coaching kids for more than 10 years. So let me show you where you can actually find it. So right now, while you're watching this video, in the community, there is a tab called as community on the channel. You go down. I have pinned the message over here. Warriors, watch the session of semiconductors for your term 2 physics board exam. Just click on this and watch it. Okay. So this is the session that you have to watch. And go ahead and smash the like button also if you're signed in. Okay. Now, right now you guys are watching this session. So let's move to what exactly I have for you in this session. Apart from the regular stuff of concepts, previous year questions, I have a very nice surprise for all of you. Hi Shweta. Hello Iris Flex. Hello Sania. Hi Vasmalati. Hello NEET 2022 aspirant. Wow, very good Rashik. Amazing. Kudos to all of you. Those of you who have completed the whole session for NEET as well. Very good Mr. Zug. Hello Shrija. Hello Kalyan. Okay. Hello Vishwanath. So I have a surprise for you. And guess what the surprise is? Well, let me just show it to you right over here. Do you see this? This is the NCRT PDF, right? But this is not any ordinary NCRT PDF. This is marked, underline, NCRT highlight. So I'm going to give you the highlighted NCRT PDF, which is basically going to help you focus on only the important concepts which are there. So all the important concepts, all the important words, phrases which you should know for your term 2 examination, I'll be sharing it in your Telegram channel. So if you have not yet joined the Telegram channel, make sure you join it right away. And if you loved the surprise and loved the gift, go ahead, smash the like button. And yes, make sure you hit the subscribe button so that you prepare the best with the best teachers in this channel. So go ahead, hit the subscribe and the like button, guys, and make sure you're in the Telegram group. Yep, very good NEET 2022 aspirant. And glad you completed the theory. Let's revise this. Love you guys. Love you guys. Telegram channel name you will not be able to search. There are only 2 ways. One is scan the code here. Second way, there is a link in the description box. Make sure you go ahead and click on that link which is right now there. Just go down. You will see it over here. Where is it? Yeah, Peepas on Instagram. That's my Instagram handle. This is the Telegram channel. Do you see that? Right over here. Just click on this link. That will take you to the Telegram group, of course. So let's begin with the class, guys. And yeah, let's start with the concepts. So we'll start with electromagnetic waves, then we'll go to ray optics, then we'll go to wave optics. Okay. Yes, NEET 2023 aspirants also can watch it, but it will be more of a revision kind of thing. I'm not going to teach you from like the detailed class. For that you need to watch Pathfinder series. Okay, now talking about electromagnetic waves. All right, so light is a wave, and wave is nothing but transfer of energy. Energy flows from one point to the other. Now light is made up of two waves which move together. It is like light handed its energy to two people. One is electric field, the second one is magnetic field. And light said, okay, you two guys, take my energy from this point to other point. Who are those two people? So those two people are the electric and the magnetic fields. So EM waves is nothing but, it's a transverse wave which carries energy in the form of electric and magnetic field. Now this electric field, you can see one is electric field, the other one over here is magnetic field. They both are perpendicular to each other. So electric field is perpendicular to magnetic field. Not just that, there is one more interesting characteristic. If you notice, these two waves are going in this direction. This is the electric field, one is magnetic field. They both are going in this direction. You will see one more interesting characteristic, and that is this one. If, let's say for example, this is your, let's say, electric field, and let's say this is your magnetic field. They are perpendicular to each other, just like I told you. If you do the cross product of electric field with magnetic field, electric field cross magnetic field vector, then guess what you get? You will get the direction of light. So basically the C vector is nothing but parallel. The speed of light is parallel to the electric field vector cross the magnetic field vector. Very, very important. So electric field is crossed with magnetic field. E cross B gives you the direction of light. Keep this in mind. Exactly, keep this in mind. Okay, next thing. Since I told you they carry energy, electric and magnetic field, these energies are distributed equally. So if you talk about the distribution is equal. Both electric field and magnetic field carry equal amounts of energy from one point to the other point. Keep this in mind. Now, another thing to notice about electric field and magnetic field is that you will notice the electric field, the magnetic field, both have the same wavelength, both get troughs and crests simultaneously, they both travel together with the same speed. So I can say the electric field and the magnetic field waves are in phase. Now when I say they are in phase, that means they have same frequency, they have same wavelength, and they are moving with the same speed. So all the things are same. They are in sync with each other. There is no phase difference. Perfect. Can electromagnetic waves propagate in -z direction, Janaram? Definitely. Why not? Yes, definitely. So accordingly, electric field and magnetic field will be in some different direction. That's all. Yes, I'm always dedicated for all of you, Aishwarya. I just did the session in Hindi. Now this is in English medium. All right. So let's do the next point. So guys, remember one thing. Since these are waves, so they will also have wave equation. So if I talk about the wave equation, it will look something like this. The wave equation will look something like this. Remember in 11th standard you have studied equation of a wave on a string. Y is a sine kx plus minus omega t. Same type of equation is there here also. Same type, no difference. Observe, E is nothing but E naught sine or cosine, you can use anything, kx plus minus omega t. Just like this one, you can also write the equation for magnetic field, which is B naught sine kx plus minus omega t. If you are wondering what is this E naught and B naught, well, I can tell you all of that. What do you think this E naught and B naught is? E naught and B naught are the maximum values of the electric field. That means they are the amplitudes. They are the amplitudes. Next thing, what is this K? K is your angular wave number. So basically it is 2 pi by lambda. What is this omega? Omega is angular frequency. So it is 2 pi f. It is 2 pi f. These are the things which you should definitely know. Now, talking about the speed of light, since I know that it is parallel to the E cross B, there is one more thing which is left, and let's talk about it. So, you will notice that the speed of light, magnitude wise, is also E by B. It is also amplitudes ratio, E naught by B naught. It is also F into lambda. It is also omega by K. It is also 1 by root of mu naught epsilon naught. All these formulas are similar. Optics is going to be there today only, Janya Studies. Yes, I'll be giving important questions, Kavita. Definitely. Okay. Omega t plus minus kx. Yes, you can use anything. Some of you are saying, sir, should kx come first or omega t come first? It doesn't matter. It doesn't really matter. Even if you can write omega t plus minus kx, it's the same thing. Doesn't matter. You can take the minus sign outside. Okay. What matters is, if it is plus, it is going in a negative direction. If it is minus, then it is going in the forward direction. So that's how it is. Okay. How omega by k? Well, see, V is f lambda. Instead of f, you can put omega by 2f, and instead of lambda, you can replace it with k. So if you substitute f and lambda, you will get omega and k over here. That's how it works. That's how it works. What is the x? X is the coordinate. So this is the x-axis. It is moving along the x-axis. Think of it like this. This is your x-axis. So at any point x, what is the electric field? What is the magnetic field? That is what this equation is telling me. This is the value of the electric field. This is the value of the magnetic field at some x coordinate. That is what it is. Can we use cos instead of sine? Yes, there is no problem. But if you use cos here, make sure you use cos here. Why? Because there is no phase difference between them. So make sure you stick to the terminologies. If you write omega t plus minus kx, make sure in the next term also you write omega t plus minus kx. Okay. Now, the same way you can also do it for y and z axis. It doesn't really matter. If you put instead of x, if you put y, what will it mean? Come on, my warriors. If I put instead of x, if I put y, what does it mean? It means the wave is not traveling in x. Where is the wave traveling? The wave is traveling in the y direction. If instead of x, if I put z, it means the wave is traveling in the z direction. That's all it means. Now, the spectrum is something which you should know along with its applications. So, first of all, the only thing you should remember is the approx range of the wavelengths. Starting with the longest wavelength. Longest wavelength is the long radio waves. Typically, their wavelengths are in kilometers. Then you get short radio waves or smaller radio waves. They are in meters or small 0.1 meters or 1 meter or few meters. After long and short radio waves, you get microwaves. They are in microns, 10 to the power minus 6 range. Then you go to infrared, then red. Once you come to red, you have your visible spectrum. Only this part is visible. From red, you go to orange, to yellow, to green, to blue, to violet. After violet, what is next? Ultraviolet. After ultraviolet, more energy comes in X-rays. After X-rays comes gamma, and after gamma comes your cosmic rays. Now, if you open up your NCRT right away, you will see that I have first of all marked all the important things. So going down over here, just going down over here, all this part is not there. So just skip it. You can see how is the electromagnetic wave generated. You should know electromagnetic wave can be generated by moving charges. A stationary charge creates electric field. Moving charge creates electric and magnetic field. So if you oscillate a charge, if you move a charge, what will it do? It will create oscillating electric and magnetic field. So just moving a charge creates an oscillating electromagnetic wave, EM wave, as simple as that. Energy density is not there, okay? You don't have the formulas, you should just know the concept. Electric field stores energy, magnetic field stores energy. That's all that is there. If you open the syllabus also, it's written qualitative, not quantitative, qualitative aspects of electromagnetic wave. Now going down a little bit below, oh my god, this is my bad work, okay, so ignore. All right, cool. So all these things, whatever I have told you is right over here. Electric field equation, the angular wave number, angular frequency, all these formulas are given in one slide only, okay? And yes, moving on. All these things are not there. Moving on, just going over here. Yes, electromagnetic spectrum, it's there here also. Now you might be confused, sir, should I remember this or should I remember wavelength? Remembering frequency is little difficult, remembering wavelength is easy. See, radio waves you understood kilometers, short radio waves meters, infrared is just below red, ultraviolet is just above violet. You should know the range of the visible spectrum. It is from 400 to 700 nanometers. 400 to 700 nanometers. Okay, I'm going to come to that, Gauri Shankar. Now, if you look at this, I have highlighted all the important aspects over here. Let's discuss this one by one because you can get application based questions. Starting with radio waves. Radio waves are typically in long wavelengths, that means kilometers and meters. Frequency wise they are very low energy, but they have very good transmission range. That means they can travel long distances because of their large wavelength. Everybody might have heard some radio station. Usually the radio stations are in kilohertz, not in megahertz. I hope you know that, right? The radio stations frequencies are usually in kilohertz, not in megahertz. Not in gigahertz or anything. So you will notice that the frequency ranges are typically in kilohertz, very extreme in few megahertz. That's it, 180 megahertz. That's all, not more than that. Okay. Now, in radio waves, apart from that, there is nothing more. In microwaves, if you see, the most important thing that you should know is how a microwave oven works. Yeah, we are going to do a question on satellite's ionosphere in a bit, Mr. Unpredictable. Radiation pressure is the pressure nightmare which light exerts when it falls on a surface. I'm going to talk about it maybe tomorrow, but radiation pressure is not there in the syllabus for boards. For JEE and NEET, I have explained it. So, light carries momentum when it falls and it hits, it applies force. That force per unit area when it falls is called as the pressure of the radiation. Okay. Now, if you notice here, in a microwave, you would have seen that when you cook the food, it's the food which gets hot, not the vessel. That is the advantage of using microwave because it efficiently heats up only the food particles. How does microwave know what is food and what is not food? The answer lies in the concept called as resonance. Now, what is resonance? Resonance is when two things are in sync, their frequencies match, then their vibrations get transferred very nicely. So, let's say there is a swing which can oscillate. And you push the swing and pull the swing with the exact same way, the way it is oscillating. The swing will oscillate very nicely. But if you pull and push it in a very weird manner, then the swing will not have a very good oscillation. So, the concept of resonance is when the external force frequency matches with the natural frequency, it oscillates, it resonates, producing large vibration. Now, it so happens that the food which you put inside your microwave, this entire paragraph is all about that. The food particles which contain water, the water molecules frequency matches with the microwave frequency. So the microwave is able to oscillate it, vibrate it very beautifully. So the water molecules vibrate, and when they vibrate, you will see that there will be good amount of thermal energy which is created, which heats up the food. Now, water is only there in food obviously like fruits, vegetables, whatever meat you have, but glass, ceramic, porcelain, they won't have water molecules. So they won't oscillate, they won't vibrate, and hence the food only gets heated up. The vessels don't get heated up. That's how it is. So you should know the principle of microwaves. This can come like, a passage or a case study or a direct application based question. Yes. So EM waves carries momentum as well as energy very well, RS, both momentum as well as energy. Because it has momentum, that's why it has force as well as pressure. Okay. This session will be for approximately 1.5 to 2 hours. Infrared waves. Infrared waves are produced by hot bodies and molecules. So even me right now, I am producing infrared waves. Right now there is a lot of light. You can see me. If I turn off all the lights, will you be able to see me? No, right? But if you wear some goggles, night vision goggles, you will be able to see me. That is what our military uses on the border to see if there is a terrorist entering inside. How do these goggles work? Very simple. Every human body, we are all warm-blooded animals, right? Unless you are a snake. A snake is a cold-blooded animal. Yes. So Ankit, don't worry. I'm going to give you the marked PDF only. So Vasumati Lakshmi, can you just please go back a little bit, rewind that part of resonance? Okay? You can replay that part, you will be able to understand. It's very simple. It's just being in sync. Yes. So what happens is, we human bodies also emit radiation, and it so happens that our radiation lies in the infrared region. So if you have a camera which can capture infrared rays apart from visible rays, then using such a camera and false colors, I will be able to see if there is a person in the dark room. Even if there is no light, the infrared rays can be detected by the infrared camera. So that is one of the uses. Also, you will see that infrared rays are the ones which are getting trapped by the greenhouse effect. Greenhouse effect is an effect where our gases like carbon dioxide and all the pollutants, they form a layer in our atmosphere, and the infrared rays cannot cut through, cannot pass through that gases. So they get reflected, and because of those reflections and that heat getting trapped, you will see the earth gets warmed up. So greenhouse effect is basically an effect where the gases trap the infrared rays because they do not allow these infrared rays to go out, and infrared is just heat coming out of everything around us. So you will see the surroundings get heated up. Heat waves, because they are coming out of hot bodies. That's the reason, white devil. Mr. Zerg, obviously the PDF will take time. It will not come now. Just give me some time. It will come by tomorrow. Yes, 0 to superhero after the boards and KVPY. Alright, next question. Yes, visible spectrum, like I told you, you should know the range of it. 400 to 700 nanometers. You should know the range, wavelength. 400 is for which color? 700 is for which color? Does our IR blaster produce heat? Yes, it produces, but it is very small. Yep. So keep this in mind. Yes. So guys, 400 is for violet, 700 long wavelength is for red. Keep this in mind. Okay. Now, next thing you should remember, in UV rays, UV is much shorter, higher frequency. So the wavelength will be lesser than 400 nanometers, and ultraviolet is very dangerous, and ultraviolet can be only blocked by ozone. So the ozone layer plays a very important role in protecting us from the harmful UV rays from the sun. If you see that the sun is shining brightly and the ozone is very weak, then those rays, when they touch your skin, can rupture and cause long-lasting harmful effects. That's why we wear a sunscreen which has good protection, value. SPF, if it has higher SPF, it is better. That means it can protect us in a better environment. So always wear sunscreen when you go out in the sun, or else you can develop skin diseases or cancers. Next, X-rays. X-rays are also useful but when used in limited amounts. If you are exposed to X-rays for a long time, again your skin will burn. It is again very harmful for your body. They say that you should never have X-ray exposure for a very long time. Oh my god, Anamika, oh my god, you spent 40 bucks. Please do a recap on diagrams in a short video. Okay, Anamika, I'll be showing you few diagrams when I do this, like the one I showed you over here. Where is it gone? The EM waves diagram, and the remaining derivation related diagrams, Anamika, I'll be doing it in the derivation session day after tomorrow. Yeah. Now, X-rays is not only used for detecting fractures, but you would have learned in a chapter called as X-rays that it is also used to determine the structure of, molecules or the structure of solids using the laws of diffraction. So it is useful for studying solid structures, detecting cracks and detecting fractures. Last one is gamma rays. That is very energetic, very high on energy, and gamma rays are very bad for your health. And gamma rays can only come from nuclear fusion or fission reactions. Very high energy. So they are used to treat cancer cells. They are used to treat cancer cells. Okay? Yep. Very high penetrating power because of high frequency. There is this beautiful table given. I want you to go through it. Which range, which wave, what is the way in which it is produced, and how it is detected. You might get some question like fill in the blank or answer in the line, what is the range, how is it produced. So you should definitely know this table by heart. Okay, cool. Yes. So Deepa, I will be conducting a special session for NEET. For now, let's focus on boards. Okay, and let's move on. Okay, let's move on to some questions. Here it comes on your screen. A radio can tune into any station in this to this range. What is the corresponding wavelength band? Wavelength band. Let's try to figure this out. Come on, my warriors. Come on, my warriors. A radio can tune in to any station from 7.5 to 12 megahertz. Guys, what is given? Frequency is given, wavelength is asked. C is F into lambda. Lambda is C by your F. So do it 2 times for each frequency. For this one, the wavelength will be C, which is 3 into 10 to the power 8 divided by frequency, which is 7.5 into 10 to the power 6. Correct? Okay, 3 and 7.5, so I can write 75 into 10 to the power minus 1. These two will go and become 10 to the power 2. This will go 25 times. So 1 by 25, that's it. I can write it as 100 by 25 into 10 to the power 3 and 10 to the power, so I can just write it as 10 to the power 1. So this will become 40 meters. That's it. And for the other guy, 12 megahertz, lambda will be how much? C, which is 3 into 10 to the power 8 divided by the frequency, which is 12 into 10 to the power 6. Mega is 10 to the power 6. This goes 4 times. So 1 by 4 is 0.25. This will be 10 to the power 2. This is 25 meters. So what is the range, my warriors? The range is 25 meters to 40 meters. That is the band. That's all. 25 to 40 meters. That's the answer. Very easy peasy. This question can come just for 2 marks. Just for 2 marks you will get free marks. Freely it is available. You just have to solve it. That's all. Moving on. Okay. It is necessary to use satellite for long distance TV communication. Why do you think you need a satellite for long distance communication? What is the necessity of that? Understand, Earth is round. If you have a TV tower and we have a Pandu over here who was interested in watching some TV, then the TV signals cannot cut through the Earth. Because Earth is round, it cannot reach there. Lot of hills, obstructions, buildings, cars, monuments will be there. So it can't reach there directly. So one would expect that, okay, I have the ozone layer or ionosphere. So I have the ionosphere. So maybe the light, the rays will get reflected from the ionosphere. There is reflection which can occur from the ionosphere, because the ionosphere acts like a very good reflector for many waves, but not TV waves. TV waves, the radio waves, do not get reflected because of high frequency. So they cannot be reflected. You cannot use ionosphere to transmit the signal from or to a large distance. Instead, what you do is you make use of a satellite. The TV tower sends the signal to the satellite, and the satellite broadcasts it. It will receive and transmit. So there is receive and then transmit, which occurs in the satellite. And that's why you will see the dishes on the houses are always pointing in one direction. Your Tata Sky or Dish TVs are pointing towards the satellite, because the satellite rebroadcasts the same signal. It acts like a repeater. Yep. So basically, whenever your frequencies are higher, then it can penetrate very easily. It can penetrate through the ionosphere layer very easily. Gamma rays have more penetrating power. Yes. Satellite follows Malu's law? No. It's not Malu's law. It is basically accepting that signal, absorbing, receiving, and then again amplifying it, making it louder, and then rebroadcasting it, just like you have your Wi-Fi repeaters. Have you seen Wi-Fi repeaters in your house or offices or some other place? There will be a repeater. Why is there a repeater? Because your Wi-Fi signal cannot reach. Hence, you use a repeater which can absorb that weak signal and again amplify it and rebroadcast it. So basically, satellite is doing the job of a Wi-Fi repeater, nothing. Okay, so yes, answers are there in a line. SR, Sri, I have put up all the answers. First I'll explain you, and then I will also show you the answers. TV signals being of higher frequency are not reflected, therefore the signals are you need to transmit them using satellites. Okay, I have put up everything. Find the wavelength of the EM wave of frequency this much hertz in free space. Give its two applications. Yes, Pankaj, why not? Why radio waves no reflection? No. Some radio waves, Nandi, they get reflected. Low frequency. High frequency, they do not get reflected. So there is a limit till which all the frequencies can get reflected. So the TV signals are of very high frequency in that small range. So they just pass through the ionosphere. So they don't get reflected. That's all. Yeah. Radio waves have less frequency. In that less frequency, the TV waves have more frequency. Understood? There are lower range. There are long radio waves. There are short radio waves. Remember? So TV comes in that short radio waves. Long, short. Long radio waves get reflected. Short get directly, passed. Okay. Yes, let's have a look at it. The wavelength of the wave, give its two applications. So I'm pretty sure you would have found this out. Lambda is C by F. C is 3 into 10 to the power 8. Frequency is 5 into 10 to the power 19. So this is 0.6 into 10 to the power, what is this? 10 to the power minus 11. So this is 6 into 10 to the power minus 12. 10 to the power minus 12. That is picometers. Pico, that's smaller than an Armstrong. That means the wavelength is shorter than X-ray. Which is the wavelength shorter than X-ray? Which is the wavelength shorter than X-ray? Wavelength shorter than X-ray. It is gamma rays. It is gamma rays. So what is the application of the gamma ray? Application of gamma ray to treat cancer cells. To treat cancer cells. Okay, you can use to treat it cancer cells. You can use it to treat tumors. I have put basically, the underlined statement in our PDF. Please go through all the applications. Yes, make sure you go through that. Also, these gamma rays are very energetic. They, you can also study the nuclear reactions. You can also study the nuclear reactions from the study of the gamma rays. All right, cool. Okay, this is not cosmic, this is gamma rays. Yes, Pankaj, because that was Hindi channel, this is English channel. So I'll be doing, obviously, for all the English students here, the same thing. Next question. No, Veera, it will end much before that. Thalapati, I will upload the PDF after the session is over. How can I upload it before? Okay. State the condition under which a microwave oven heats up the food items containing water. Name the radiations which are next to these radiations in electromagnetic wave spectrum, which are having smaller wavelength and which are having longer wavelength. Come on, my warriors, figure this out. Do we not need to learn frequency range? No. You need to learn the wavelength range, Janaram. Very good, GUI. Yes, it is resonating frequency. So the condition is basically resonance. And when I say resonance, it means the frequency of the microwave matches with the frequency of the water molecules, because of which they start vibrating. They gain lot of energy, and because of that energy, that converts it into heat, and you will see the temperature rises. That is the logic for the first part. If you look at the second part, which are the radiations next to the microwave radiation? I've just told you this right over here. Next to microwave, you have more shorter wavelength, which is infrared. Longer one is radio wave. Infrared and radio, just adjacent to microwave. Hence, that is the answer. You can see right over here. Yep. So it is infrared and radio waves. Infrared will have your shorter wavelength, and radio waves will be longer in wavelength. Keep this in mind. Next question. See, Alexander, if you open up NCRT now, you will see the difference very, very clearly, that in X-rays, look at this. Look at this, X-rays. Okay. X-rays can damage the tissues and organisms. Care must be taken to avoid unnecessary exposure. So it causes damage. Even gamma rays are damaging, but if you use it correctly, it can be used for treating cancer, not X-rays. Only gamma rays are used for treating cancers. X-rays are used to detect cracks and fractures. That is the difference. Okay, I hope that difference is clear. Yes, I told you, right, Hariharan, just remember the wavelengths, not the frequencies. Yep. Okay, come on, let's move on to the next one. Okay, what is this? What is the wavelength? What is the amplitude? And what is the energy density comparison with the magnetic energy density? Okay, so let's try to do it one by one. What is the wavelength? Come on guys, this is very simple. Lambda is C by F. C is 3 into 10 to the power 8. Frequency is 2 into 10 to the power 10. So this will be 1.5 into 10 to the power minus 2 meters. So that's your wavelength. First answer done. Second answer, what's the second question? Find the magnetic field's amplitude. Okay, so we all know electric field by magnetic field is speed of light. So magnetic field amplitude, take it on the top, C comes below. It will be E naught by C. What is the value of E naught? It is clearly mentioned. Electric field's amplitude is 48. So this will be 48 SI units. C is 3 into 10 to the power 8. 48 by 3 is 16. This will be 16 into 10 to the power minus 8. Obviously units, do not forget, if you miss the unit you will lose half a mark. So always remember to put units after every answer, and whenever you get an answer in the board exam, do not forget to block it so that teacher can see, the examiner can see where is the answer. Else they will just think that maybe you have not solved it, they might cut half a mark. So always block the answers. You might just end up annoying the examiner. Talking about the electric field energy, and there is, I think, magnetic field over here. Which energy is more? The answer is they both are equal. The electric field energy and the magnetic field energy. In fact, if you add them, you get the total energy of that electromagnetic wave. So there is no partiality over there. Electric field and magnetic field both carry same equal amounts of energy. Keep this in mind. Radar system is in microwave or not? It's slightly beyond microwave if you notice. Okay, just 1 second. I'll just put it over here. Yeah, just go back a little bit. It's slightly beyond it if you notice. So look at this. Microwave comes to the left side. Radar waves are there. These are basically short radio waves. Okay? Then you get medium range radio waves. Then you have long radio waves. So radar comes on the extreme end of the radio waves, the higher frequency of the radio waves or shorter wavelengths. If you go shorter, then you reach microwaves. It's on the borderline. Okay, come on, let's move on to the next one then. Ready, guys? Okay, let's move on. Okay, where are we? Okay, yes, that's the answer. Yes, we just got it. Perfect. If the Earth did not have atmosphere, would its average surface temperature be higher or lower than what it is now? Okay, come on, guys. If Earth did not have atmosphere, what do you think will happen? Will it be lower or will it be higher? And what is the reason? They will ask you why. Why also? Somebody is saying higher, most of you are saying lower. The correct answer is, it is lower. It's all got to do with your greenhouse effect. Because of the greenhouse gases, you will see the infrared rays get trapped. They cannot escape. But if there are no gases, if there is no atmosphere, where will the rays get trapped? They will not get trapped. So the infrared rays will just flow out. So because of which our Earth will cool down. That is the reason why we don't want to use petrol, diesel cars or burn coal, because these produce greenhouse gases. They end up warming our planet. If these gases are not there, there will be no warming, there will be no global warming, and you will see that the Earth will be a much cooler place. Yeah, that's how it is. Shortest wavelength, even before gamma, there is one more called as cosmic Bharadwaj, but cosmic rays are not there in our syllabus. Don't worry. Cosmic rays have even higher frequency or shorter wavelength. Okay, let's move on. Ray optics. Are you guys ready for ray optics? Let's move to ray optics revision. Let's open up that chapter. Let's open up the chapter, guys. Okay, ray optics. Now in ray optics, guys, you don't have reflection for boards. How lucky can you be? No concave convex mirrors, no plane mirrors, nothing. Straight away, you guys are really lucky batch, guys. I think you are the same batch who did not write the 10th standard board exam, was it? Acha, very lucky batch, somehow. Okay, yeah, please bring the book, no problem. Hello, Sriram. Acha, that was your senior batch. Oh, sorry, you wrote. Acha, your junior batch did not write. You wrote. You wrote the 10th. The 2020 batch. Okay, okay. So, but good thing, lucky thing, so much syllabus is deleted. Okay, so in refraction, I want you to see the page number 316 if it is the same one in your book as well. Now, one thing that you should know is, look at this diagram. Whenever light falls on anything, one of the three things can happen, or all the three things can happen. One is the light can get absorbed. Second is light can get reflected. Third thing is light can transmit. Now if you take a mirror, most of the light gets reflected. If you take a perfect glass, most of the light will get transmitted. If you take a black surface, most of the light will get absorbed. So, depending on the material, the light can get absorbed, reflected, or just transmit to it. The light which gets reflected, follows obviously laws of reflection. Angle of incidence is angle of reflection. Simple. But that light which passes through, transmits, that is called as refraction. That light ends up bending. It will follow Snell's law. Snell's law. Bharadwaj, I'll be explaining sign convention. Don't worry. Okay? Okay. So, moving on to the next thing. So, let's try to see what are the important things over here. I'll be giving you all the laws, Snell's law, and you should also know the phenomena which are affected by refraction. This can come like a give reason. Why does the sun appear to be, little bit before or after the sunrise or sunset? Imagine the sun is here. This is where you are. This is the atmosphere. Atmosphere also has some small refractive index. Very small. So the atmosphere refracts the rays. So the rays of the sun bend and you feel that the rays are coming from somewhere else. So actually when you look at the sun, believe me, the sun is not there. The sun is somewhere else. The sun is somewhere else. Yes. So when you see the sun here, sun is somewhere here. So that's why what happens is, because the rays can bend, even before the earth turns, you are able to see the sun because of the bending effect, refracting effect. Twinkling of stars is also because of refraction. The rays of distant stars, they pass through different layers of the atmosphere, and because of the rapid movements of the layers of the atmosphere, clouds, wind, hot, cold air mixing, turbulences, the refractive index changes. Because of those changes, the light rays keep shifting left, right, down, bottom, whatever, because of which the twinkling effect happens. Twinkling effect happens. Okay, you should keep this in mind. Now, all this is fine. Then you come to total internal reflection, but before that, let me just give you the formulas. Talking about refraction over here, let us say this is your medium, this is your medium 1, this is your medium number 2, this is your normal ray, this is your normal ray, and this is your incident ray, this is angle of incidence, this is your refracted ray, this is your angle of refraction. According to Snell's law, what do you get? You get sine I by sine R for a given pair of medium is a constant. It is also C1 by C2, which is 1 mu 2, which is mu 2 by mu 1. If you are wondering what is the difference between these two mu's, well, let me tell you that as well. This is your relative refractive index, because when I write two subscripts, it's the refractive index of 2 with respect to something. Glass with respect to water, water with respect to diamond. So whenever you compare two different mediums, it is called relative refractive index. Samir, derivations will be done day after tomorrow in a special session. This mu 2 or mu 1, they are your absolute refractive index, because they are measured with respect to nothing, basically vacuum. Keep this in mind. Not just that, even this formula gets changed. I mean, you can modify this. Speed is frequency into wavelength. Speed is frequency into wavelength. It's the frequency which does not change when the medium changes. So it is just lambda 1, lambda 2, frequency gets cancelled. Keep this in mind. Very important stuff right over here. You should also know the refractive index of certain things, like refractive index of glass is 1.5, refractive index of Water is roughly 4 by 3 or 1.33 standard values. Some things which you should know. Total internal reflection, it's happens when light goes from which medium to which medium? Hi Neonjos. If rays pass from air to glass, which should we take as 1 and which should we take as 2? Jana, it is very simple. If light goes from monkey to donkey, monkey comes first, then donkey comes next. That's how the numbering is done. If it goes from glass to water, glass first, water next. Air to water, air first, water next. Water to donkey, water first, donkey next. Understood, bacha? The refractive index of vacuum is 1. Okay. So now total internal reflection occurs only when the light goes from a dense medium. Let's say the refractive index is mu, to a rare medium. Let's say example air. So a rarer medium, example air. So usually what happens when light is incident at a very small angle, it bends away from the normal like this. If you slowly increase the angle, you will notice the angle of refraction also increases. As you can see, there is a limit for it, and that limit happens right over here. So when you increase the angle so much that the ray almost turns out to be parallel to the surface, that means this is 90 degree, this becomes your incident angle. This angle is the critical angle. Because why is this called as the critical angle? Because if the light rays are incident more than this angle, you will see the refracted rays have nowhere to go. You have used the maximum angle. After this, the light rays can do only one thing, and that is total internal reflection. Even if you put it here, you will see it will just follow reflection laws. This is your critical angle, the one in blue. And the formula for that, sine of IC is 1 by mu of that dense medium. Very important. I have a question for you over here. If some material has higher refractive index, like for example diamond has a very huge refractive index. Aisa Javer, you will get it in our Telegram channel later on, not now, tomorrow. Then what will happen to the critical angle? Karthik saying low critical angle. Yes, Mr. Zog, it will have very low critical angle. When it has very low critical angle, it just means one thing. It means that the light rays have a very good chance that they can just get internally reflected. Because low critical angle means not many angles are available with me for the light rays to come out. This green zone gets reduced. The red zone is more. So chances of it getting internally reflected are more. And that's what you will see in total internal reflection. You should know the definition. Light goes from dense to rare, then the light rays cannot come out, they just get reflected. That's one thing over here. Okay, no light transmission takes place. Transmission is 0 in total internal reflection because everything gets reflected. You can see this table. As the refractive index increases, critical angle decreases. For diamond, refractive index is large, critical angle is least. And you should know the different phenomena associated with total internal reflection. Total internal reflection. What are the phenomena? First is mirage. Then also you should know about optical fibers, prisms, diamond, all these things. Mainly this mirage can come like an explanation. Explain the formation of a mirage. What is total internal reflection got to do with a mirage? Look at this diagram. Look at this diagram. You will realize it. Excuse me. I don't have corona. Okay. So guys, when you are in a desert-like environment, the ground is hot. Whenever the ground is hot, the air near the ground is also hot. As you go on the top, the air becomes really cold. When the air is hot, it expands, the density goes down, the refractive index is also less. When you go to a cold region, the air compresses, density increases, refractive index is also more. So if you had a light ray which is coming from a dense medium to rare medium, dense to rare, chances of internal reflection also are there. Hence, what happens is, if you draw a normal, you will realize that the light bends away from the normal because it's going from dense to rare. And there might just come one angle which is more than the critical angle of incidence because you are going from dense to rare. And the moment you cross that critical angle, the light will get internally reflected. And that's why the light bends like this. If you're wondering, what is this? Is this like Rajnikant? He's bending light like this? My God. So guys, this is not Rajnikant bending the light. It is total internal reflection bending the light. And this guy out there feels that the light rays entering the eyes are here. So he feels, he perceives that the light is coming from here. He feels this object is right over here. That's the concept. Okay, moving on. Okay, so this is what you should know. Also, you might get questions on optical fiber. Optical fiber feels like Pushpa. Yes. So optical fiber network is where, you want to transmit signals without minimal losses, without losses basically. Now, usually in current, what happens because of the resistance, external factors, the voltage gets affected, the current reduces, and you will not be able to transfer all the energy through wires because there are some losses, resistance. But if you use light and pass it in a dense medium and cover it with rare medium, pass the light through a dense medium and cover it with rare medium, then the light, once it is trapped inside, it will find it very difficult for it to come out. You will see that internal reflection occurs. It will keep bouncing. It is not able to come out. Eventually it will come out on the other side, which is receiving end, and you will see that almost 95% of the light gets transmitted because a part can be absorbed, but otherwise most of the light gets transmitted. Very important phenomena can be asked. Cool? Yes. The case studies are I'll be taking up special lecture just on questions, but I'm telling you, case studies can come. Like I told you, on this, case study can come on mirages. I told you, case study can come on the application of EM waves. So when I'm teaching you only, I'm telling you, case studies can come on these topics. Yes. Yeah, even if the where is that? Optical fiber network bends, it doesn't matter, it cannot come out. So it will just follow the path of the optical fiber. Yes, NCRT questions are very important, Nikita. Yes, okay. Come on, let's do the next part, which is refraction at spherical surfaces. Coming to this point. Okay. Now, when I say refraction at spherical surfaces, you should think about, you can think about lenses, you can think about, I don't know, maybe even look at this bottle right over here. It's a curved surface. If something is, wow, what noise. If something is inside, when it comes out, the light rays come out, they bend, they refract at the curved surface, and I might feel that the object is somewhere else only. So, refraction at curved surface. Let's see the formulas. First of all, this is my curved surface. Okay, this is my principal axis. This is my pole. This is my radius. This is my center of curvature. I might place the object maybe over here. Object might be here. The rays of light will go like this. This is actually the normal. This is your angle of incidence. Finally, the ray might bend and it might travel like this to form the image over here. Wherever the incident light is, that refractive index is called mu1. Wherever the refracted light is there, that medium's refractive index is called as mu2. This distance is called as object distance. This distance is called as the image distance, u and v. Then the formula works out to be mu2 by v minus mu1 by u is mu2 minus mu1 by r. That's all. Now, talking about sign conventions, it's simple. If you have any device, and the light rays are incident like this. Remember, the sign convention always works in the same manner for lens, for mirrors, for curved surface, anything. All you need to remember is that device, in this case the curved surface, is always the origin. This line becomes your axis. The direction in which the incident light goes becomes your positive direction of x. So this becomes your positive side. This is origin. So this becomes your negative side. All the points to be treated like coordinates, and just remember, when you write the signs, you just have to think about the coordinates. That's all. Just to give you an example for this guy. Take the example. Here, the radius, if you look at the radius of curvature, is the radius going to be positive or negative? Yes, Janaram, it is very simple. Is the radius positive or negative? Many people think radius, they draw an arrow mark and they look at the arrow mark. No, don't look at the arrow mark, just look at the coordinate of the center of curvature. Center is here. Light rays are going like this, so this is positive, this is negative, so the radius will have a positive sign. Think about it. If you look at the object, it is on this side, it is on the negative side, negative coordinate, so u is going to be minus. Image is on this side, so it will be plus. That's how it works. So just mark the device as the origin. This is the sign convention. Draw the direction in which incident light is going as the positive direction. So this side becomes positive, this side becomes negative. If light comes from there, then this becomes positive, that becomes negative. Look at incident direction. Okay, I'm ahead of you in time. Are you from UAE or something? Maybe. Yes, we will be doing numerical, Sanjit Krishna, definitely. Oh my god, neat. You can even if you're lost half an hour, you can go back even during a live class. Let me tell you that. Yes. Can I write N2 by V? It's the same thing. Mu or N2, mu1 or N1, same thing. Just the different books use different notations. Okay. Now, when we talk about lenses, lenses are two surfaces together. So let's say, for example, this is a lens, and this can be also a lens, fair enough. And wait a minute, let me just show. This is the first surface, so this is my radius of curvature R1. This is my second surface, that will have some radius, it's a part of a big sphere. This is R2. If this is a concave lens, this is my first surface. If light is coming from here, this is R1, this will be R2. So I have a formula right over here, which is called as the lens maker formula, which tells me if parallel rays of light come, where will they meet? They will meet at the focal point. So that is your focal length. Here, when they come, you will see that they diverge from a point over here. This becomes your focal length. Now, think about it. In case of convex lens, light is going that side. Light is going that side. So that is the positive side. Look at this. This is the positive side. This is the negative side. Same way, the light is going this way. This is your x-axis. This is your positive side. This is your negative side. So you guys only tell me, is this focal length positive or negative? is this focal length of the convex lens positive or negative? Come on, my warriors. Is it positive or negative for this convex lens? It's on this side, focal point. It's positive side. So F is positive. F is positive. If you look over here, for concave lens, where is the focal length? Think about it. Focal point is on this side, negative side. So focal length is negative. Fair enough. Let's move ahead. If I talk about R1 and R2, most of the confusion happens here. Let's do this, my warriors. Proud of you, bacha log. Most of you, 90% have answered this correctly. Very good. Very good. If you talk about R1 in the convex lens case, is R1 positive or negative? Think carefully. R1's center is here. It's on the positive side. So R1 will be plus. R2's center is here. So R2 will be minus. Similarly, if you look over here, if you notice, R1's center of curvature is this side, so R1 is negative. R2's center of curvature is here, so R2 is positive. This is how the sign convention works. If you know this, that's it. Done, done, done. 2023 Abhishek in a few days. Just give me some time. So, what's the formula that you need to know? The formula that you need to know is called as the lens maker. When you make a lens, I need to know what radius, what material I should use to get the desired focal length. So, lens maker formula, and that is given by 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. This mu is the refractive index of that material which is used, and guess what? The power of the lens P is just given by 1 by f. It's just 1 by f. Yes, you should focus on theory more than the numericals, white devil, because board exams has most of theory, case studies than the numericals and the derivations, definitions, diagrams, etc. Okay, keep all these things in mind. Moving ahead, lens formula now. We are talking about lens formula. So if you have a lens and now you found the focal length, and if I place an object here, I know that the image might be formed here. So 1 by V minus 1 by U is equal to 1 by F. This is called as just lens formula. Not lens maker, just lens formula. Last thing is magnification. Magnification M is image height. How much is the image height? By the object height. This is given by V by U. Standard. For mirrors, concave mirrors, it was minus. Here it is just V by U. Sign convention for V and U is the same thing, Bharadwaj. Look at this. Same thing. How is the light going? Light is going like this. So which becomes your positive side? Light is going like this. So this becomes your positive x-axis. So this is positive side, this is negative side. So object distance will be negative and image distance will be, in this case, positive. That's how it works, as simple as that. Just have to see the direction of the light. Okay, angular magnification will come later on. Silvering of lenses is not there, Sriji, don't worry, it's there in JEE, and I have taught that in the JEE section. Don't worry about it. Okay, now let's go to prisms, but before that, let's also see if we have some important point over here that we have missed. Derivations I'll be doing in a separate class, please keep this in mind. Just standard questions, derivations, same formulas, whatever I have told you. Okay, Acha, this is one paragraph which is kind of important, but I'm pretty sure you know the rules of ray diagrams. Whenever you have rays and they ask you to draw ray diagrams, you should use one of these three rules. A ray parallel to the principal axis passes through the focus or appears to pass through the focus after passing through the lens. Second rule, a ray passing through the pole goes undeviated. This is your second rule. Third rule, a ray which passes through the focus becomes parallel after refraction. These are just three rules which you should know for drawing the ray diagrams. These kind of questions can also come. You can also be asked to state those rules. If the board examiner is very lenient, that question can also come. Image height by object height given, power of a lens also done. Oh yeah, remember the common mistake in power is many students forget to convert focal length into meters, so keep that point in mind. Okay, power is positive for converging lenses because focal length is positive. Power is negative for concave lenses because focal length is negative. Also important. Okay, it's combination of lenses. Yes, this is another important thing. If you have 1, 2, 3, 4, 5 lenses tuck arranged one after the other, then the net power gets added, but it is the reciprocal of focal lengths which get added, just like resistors in parallel. So P1 plus P2 plus P3 is the net power, and focal lengths inverse gets added. Keep this in mind. Also, the magnification does not get added, magnification gets multiplied, M1 into M2 into M3. Janaram, I'll be talking about both the differences when I come to optical instruments. Just hold on. Okay, is there any possibility to get into IIT? Yeah, definitely. Please put up a comment after the video and I'll definitely reply to your comment. Yeah, capacitors in series too. Okay, magnification multiplies, focal length inverse adds, powers just add like series, P1 plus P2. As simple as that. So that is something which you should know over here. Oh my god, oh my god, oh my god. Why is it becoming bigger and bigger and bigger? Now let's come to prisms. Minimum deviation, dispersion is not there. Don't worry about it. Okay, it's not there in your board syllabus. I mean, how lucky you guys are. My god, I'm so jealous of you guys. I studied, I mean, not just term 2, term 1 plus term 2, the entire 12th standard portion, not just me, so many other students. Very lucky batch. Okay, so RK Gupta, how about we connect one-on-one on my Instagram handle, or you leave a comment after the video ends. How about that? Okay, so let's try to do this. So in prisms, we have the first thing which you should know, it is called as the angle of prism. Next thing which you should know is if a light ray is incident over here, this is called as the incident ray. It refracts. This ray is called as the emergent ray. This angle I1, this angle I2. I1, I2, incident, emergent. This is R1, this is R2. Some important things which you should know over here is these two internal angles, R1 and R2. If you add it, you will get A. And these two angles are also related. I'll tell you how. First of all, let me show you. If the prism was not there, then the ray would have just gone over here. So the ray has tilted, deviated by this much angle. This is your angle of deviation. And A plus delta is I1 plus I2. Very important relationship. Yes, you will be getting the session PDF. Yes. I will be able to reply RK Gupta. Don't worry. I reply to as many comments as possible. Whenever possible, you would have seen that. Next thing, if you change the angle of deviation, you will see, if you change the angle of incidence, you will see the deviation also changes, and the deviation is minimum for a very special case. And that is shown graphically. If this is incident, if this is deviation, you will see that the graph looks somewhat like this. The deviation is minimum when I1 equals I2 and R1 will also be equal to R2. And when this minimum deviation occurs, mu is equal to sine of A plus delta minimum by 2 upon sine of A by 2. This is something which you should definitely know. No, can we consider A for all prisms as 60? No. If it is equilateral prism, then A is 60, else it could be 45, 30, I don't know, 37, anything. Keep this in mind. Okay. Now, next thing is the last part of this prism, and that is called as thin prism. where the angle of the prism is so small, it's so small that I can say sine theta is roughly theta, and I can make many approximations, and then you will see that the deviation just comes out to be a into mu minus 1. This is only true for thin prisms. Okay, Sriji, this formula comes via geometry. The angle of prism plus the deviation via geometry, I'll derive it if you want day after tomorrow, is equal to incident angle plus the emergent angle. That is another relationship. In fact, both these come via geometry. Yes, is the prism graph important? Yes, it is. You have to know that. They can ask you to derive, they can ask you to show the graph, they can ask you some graph or case study based question, graphical based question as well. Yes, sure, Clash. Definitely RK Gupta, I'll definitely reply to you, don't worry. Okay, now having said that, let's go and have a look at this. Dispersion, like I told you, is not there. All this, forget it, straight away go to not even the eye is also not there. You guys are so lucky, man. I mean, really, you should be happy. If you don't get 35 out of 35 now, you had it. I will never do lectures whatever you are asking. Okay, you better get 35 out of 35 after this. Sir, how lenses undergo chromatic aberration and how can we rectify it? It's through combination of lenses you can rectify it. Chromatic aberration, chroma means color, aberration means problem or error. So there is an error in color because each color has different refractive index, different focal length, so the image is not clear. So basically you use the concept of prisms where you have a concave lens and then a convex lens. So you will see a converging and a diverging beam rectify each other and they average out the errors so that the errors are as less as possible. Yeah. My god, chroma means laptop sword. Oh my god, this was the best joke. Revenant, my god, you just nailed it, bacha, nailed it. Yes. Oh my god, dad jokes. Revenant is very old. Oh my god. Hello, Jay Ajinkya. Can you use mirror in telescope? Yes, you can use mirror in telescope too. Telescopes, microscopes can be of different types, but what we have in the syllabus is very simple. Talking about the microscope, the ray diagrams are very important with the formulas. The ray diagrams. Yes, you will definitely get 20% off on chappals. Rashik, Rebecca. Oh my god, looks like you were there in the session. Okay, so ray diagrams are important, the formulas are important. Same thing, even in simple microscope, the ray diagram is important and the formulas are important. And telescope also, ray diagram and the final formula. Resolving power is not there. Forget it, resolving power is not there. Okay, let's do this. Now, yes, Jay Ajinkya, you have studied this from Pathfinder now. Definitely you will find it easy. Definitely. All the students. Hi Padma Priya. Hello everyone. Yes. Wow, Rashik, you have been there in all the sessions. I'm so glad. So talking about pendulum and sorry, what pendulum? I'm thinking of simple pendulum. Oh my god, guys, what has happened to me? Looking at that word simple, I thought about simple pendulum. It's simple microscope, guys. Okay, so talking about magnifying power and magnification. One student asked, sir, what is the difference between them? Telugu Radu, Ganesh Vatmuli. నీ పేరింది బాగుంది గణేష్ వత్ములి నీవు బాగుంది okay, some lines I can understand. I watched Telugu movies, Radhesham and so many, Bommerillu, Boys, Happy Day, what is that, Happy Days and so many other things, but yeah, little I can understand. Okay, so ray optics, simple microscope, what is the difference between magnifying power and magnification? I think I have taught SHM somewhere. Yes. Okay, so guys, first of all, when I say magnification of a lens, it means image height by object height. Image was 5 meters, object was 2 meters, 5 by 2, 2.5. It has become 2.5 times height wise. But magnifying power has got to do something with angle subtended by the object or the image. Now, if you take an object, it subtends an angle on your eye. On your eye, oops, why am I drawing the eye like that? Okay, so this is your eye and it subtends some angle, let's say theta, on your eye. This is your object. Now, if you get it closer, the angle subtended will be also larger. It will appear more clearer and bigger and better. So you might think the closer I get a clear image of the object. Very true. But there is a problem in that. There is a problem in that. What is the problem? Derivation Jennifer Nofia, I'll be doing it day after tomorrow. Stay tuned. 7:30, 7 o'clock. Yeah, make sure you are there. The problem is when you get closer than 25 centimeters, which is the least distance of distinct vision. The problem is after that I cannot see it. You can try it out. You bring your finger or pen closer, your eyes will be strained. You will not be able to see it. So below this you cannot extend it. This is the maximum angle which can be subtended. Now this type of eye is called as unaided eye. Aid means help. Unaided means without help. So this eye does not have help. Now if for example you use some optical instrument, maybe a specs, maybe microscope, maybe telescope, maybe magnifying glass, because of which then image is formed. This is an image of the object which is formed, which is bigger, and now it subtends an angle, let's say, I don't know, theta 1, maybe I can call this theta naught, whatever you want to call it. Now on the eye, I will call this eye as an aided eye. It is an eye which is helped. Then this angle by this angle is called as the magnifying power. What is this called? Magnifying power. This is called as the magnifying power, and this is basically theta naught by theta 1. Got it now? Do you now understand the difference between magnification and magnifying power? Magnifying power is the ratio of the angle subtended by the object for an unaided eye upon the angle subtended by the image for an aided eye. Object for an unaided eye upon image for an aided eye. That is how it is. Perfecto. Moving ahead. Oh, I wish I could teach in Tamil, Jagdish. I would love to teach in all the languages. But I'm guessing you guys are in English medium, so I think it's better to probably teach in English. Okay. Will focal length change if combination of lenses kept in liquid with the same refractive index? Yes, definitely. Definitely it will change. Last thing over here, microscope. You will see that there are two magnifying powers. If you hold the magnifying lens such that the image is formed very close to the eye, least distance of distinct vision, then the magnifying power is 1 plus d by f. When it is close, it's the maximum. But you hold the lens such that the image is formed very far away, so your eyes are relaxed. That is normal position. So magnifying power when your eyes are relaxed, then it is d by f. It is less, here it is more. These two formulas are important. Similarly, for a microscope, aided and unaided, Sriji, aided means with help, like a microscope, glass, spectacles. Unaided means nothing, you're just seeing it normally, that's all. Okay, it will have more theory, less numericals, Jennifer Nofia. If you have watched my strategy session, I conducted a strategy session just 2 days back. How to get 35 out of 35. I've done the analysis, how much theory, how many derivations, etc. Watch it, you will realize numericals are very less. I've also explained how you can score centum, complete marks over there. Okay. Nandini, please bacha, don't get tense. That is the reason why I'm coming here. I would feel very bad if you are still tense. Please watch with full faith and confidence all the classes. I know some things you might not have studied. You might have done a lot of mistakes. You have a lot of regrets. It is okay, perfectly understandable. I am there. I have faith in you. You don't lose faith in yourself. Even if your parents are scolding, even if your teachers are scolding, it is okay. Please remember that you can still crack it. Let me tell you, there were many students in term 1 who were, with me in the last few days. Last 1 week, I conducted a similar marathon session for term 1 examination, all chapters, whatever, formulas and most expected questions. Many students got very good marks. Some of them got full marks through YouTube. It's crazy. So guys, don't worry. I'm there with you. Have faith. Yes, derivations will be there. Numericals will come from all the chapters. Padma Priya, Tamil Selvan. Hi Sahana. Okay Nandini, don't worry. So glad. Thank you so much Aarthi. Rashik was also there. KVPY Shreyas. Bacha, KVPY people have screwed it up so much. I don't know what else to do. They could not think of one proper date in spite of shifting it 3 times. 3 times, they shifted. And then when they finally put it also, they put it 2 days after physics exam. What nonsense is that? Really. It should have been so nicely placed so that we could have spent some time on it. Now, many students are obviously worried about boards. So guys, please, if your boards don't go well, that is bad. So make sure you concentrate on boards first. Boards, yeah? Because KVPY, even if you get it good, but board marks are going to stay with you. Unless you are purely research oriented, don't worry. Even advanced marks can get you in. Mains marks can also get you very good college, but maybe not research, but advanced marks can still get you in. Don't worry, guys. Yes. So, Shreyas, for you KVPY is important, please watch my previous classes of KVPY. Okay, now let's talk about compound microscope. So, in compound microscope, you have something called as the eyepiece. This is the objective. Here you have that object. That's why objective. This is where your eye is. This is the length of it. This is the length of it. And length of the microscope is the distance between the 2 lenses. And you will see that the magnifying power is, this acts like a simple microscope. Always remember, the eyepiece acts like a simple microscope. Simple microscope, that means your magnifying glass. So D by FE comes over here, and here you will get length by FO. This is one additional factor which gives you the total magnifying power of the compound microscope. This is the formula which you should know. Next thing, in case of telescope, the eyepiece is bigger. My bad. Objective is bigger. The objective is bigger. The eyepiece is smaller. The objective is large because it has to collect lot of light. Number 1. Number 2, to avoid diffraction effects. The diffraction can lead to very bad resolution. So that's why the aperture is very large. Also to increase the intensity and the clarity of the image. So this is where your eyepiece is, and the object is generally very far at infinity. This is the length of the telescope. Distance between objective lens and eyepiece lens. You will notice that the length is focal length of the objective plus eyepiece, and magnifying power is F0 by Fe. Very simple standard formulas. Experiments, Kavita, they are not there. It's done in practicals. Which other experiment is there? Oh, guys, did I do unaided by aided by mistake? Oh my god. I'm so sorry. I'm feeling so bad about this. My bad, guys. Thank you for pointing it out. Obviously, it has to be the bigger number by smaller number. I'm so sorry, guys, about this. So, thank you for correcting me. I'll write it right over here. Yes. So it will be basically aided will be larger, so it should be theta 1. Unaided will be smaller, this will be theta naught. Correct. This will be theta 1 by theta naught. Yes. The bigger number by the smaller number. Bigger number will be the one when you have an aid. Aid means help, so it will be bigger. And when there is no aid, then it will be smaller. Yes. Okay, cool. So these are the formulas which you should know. And like I have shown you, that's the only important thing you should know about optical instruments. Apart from the ray diagrams. Okay, a light wave enters. So let's go to questions. Light wave enters from air to glass. How will the following quantities be affected? Energy of the wave, frequency of the wave. No problem, Renavan. Thank you guys for understanding. Yes, length is u0 because you will see that the image is formed very close to the other lens. That's the reason for that. Energy remains the same. Wrong. When will the second mock test release? Second mock test should be there in the description box. We'll check it out in a bit. Okay, Syed, Adrian. Yeah. So guys, no, energy won't remain constant. Frequency remains the same. Remember, I told you whenever light falls on a medium, partly absorbed, partly reflected, partly transmitted. So obviously the energy will decrease. The one which goes from air to glass, it will be less. Some will be reflected, some will be absorbed. Hence it decreases. Second thing, frequency remains same. I just told you mu is C1 by C2, which is F into lambda 1 by F into lambda 2. F gets cancelled because it remains unchanged. It's the wavelength which changes, speed of light which changes. And remember, color, the color that you perceive, is it because of the wavelength or is it because of the frequency? Lot of students have this confusion. Is it because of the frequency or wavelength? If wavelength changes, then color changes, or if frequency changes, then color changes. Very interesting question. Okay, Kritika saying wavelength. Sure? No, it's not wavelength. It is the frequency. Yeah, it is the frequency, guys. Okay, I'll tell you one simple fact. Okay, don't believe me? Okay, fine, no problem. Just imagine, I have a green color bulb. It will appear green to me? Okay, next thing. I take that green color bulb, put it inside water. Or I have it normally in air only. I'm swimming inside water. That green color light will still appear green color only, not to me. It will still appear green color to me. When that light goes from air to water, frequency remains same, wavelength change, but still I see the same color. That means color depends on frequency. Got it? So keep this in mind. A lot of people think that it is wavelength. Moving on to the next question. Sir, atoms and nucleus chapter teach panunga, sir. Teach panunga, Prem Kumar. Tomorrow teach panunga. Yes, I think I know panunga. Panunga means you will do, no? Yes. Thank you, Sriji. Hello, Pranita's world. So the next question. The refractive index of glass is this much. What is the speed of light in the glass? Speed of light in vacuum is this much. Panuven, sir. Okay, Panuven. Okay, Panuven is the reply. Yes, I learned the new word. Panunga, I will do Panuven. Yes. Is the speed of light in glass dependent on the color of the light? If not, which of the two colors, red and violet, travel slower in that glass? Hello, B. Monica. Okay. Cool. Let's have a look at this. Simple, dimple, easy, pimple. Oh my God, what is this? Simple question it is. Guys, mu is C by C, C1 by C2. When I write this, light has gone from 1 to 2. Here, let's understand what is 1 and what is 2. 1 is air, 2 is glass. So this is air, this is glass. So what is mu? 1.5. What is C1? C1 speed of light, which is 3 into 10 to the power 8. Speed of light in glass, Cg. So Cg will be 3 by 1.5, which is 2 into 10 to the power 8 meters per second. Done, done, are done. Now the second part is the tricky part. जगदीश मला खूप चांगलं मराठी येतं, टेन्शन नको, एकदम झकास आहे मी. Okay, now Shabina 4 is getting very late for what, bacha? Where do you have to run? Okay, you have to study. Okay, I have to complete the topics. Where do you want to run? Is the speed of light dependent on the color? Yes, it does depend. Color decides refractive index decides speed. Second part, which color travels faster? We know that violet deflects the most of all the colors. Violet deviates the most. Hence, refractive index is higher. Hence, speed of light is less. So, violet is slower in glass than, no, it's not faster, it is slower. It is slower, not faster. It is slower. Violet is slower. Yes, it is dependent. It is violet color and it is 2 into 10 to the power 8. It is given independent. Who said it is independent? Is the speed of light in the glass independent of the color? No. Did I say yes? Oh my God. Sorry. It is independent. So it is not independent. It is dependent. Yes, it is dependent. Okay, cool. Moving on to the next question. Wow, what is this? Find the radius of curvature of a convex surface of a plano-convex lens whose focal length is given, refractive index is 1.5. Let's try to solve this question. Let's draw a plano-convex lens. This is principal axis. The light rays will come like this maybe, and I don't know, they will meet over here, which is the focal point. And we have been given the focal length, and it's a plano-convex lens. Focal length is on this side, so focal length is obviously positive. I think I should use lens maker. 1 by f is mu minus 1, 1 by r1 minus 1 by r2. Focal length is this one, and I just showed you it is on this side, so positive. So just put plus 0.3. Mu is given 1.5 minus 1. 1 by r1. Now this is the catch. This is a flat surface. If you have a flat surface, it's not curved, what's the radius? A flat surface has infinitely large radius. So the radius is infinity. Whereas this part has some radius. Tell me whether it is positive or negative. Tell me whether it is positive or negative quickly. This R1 is infinity. R2, is it positive or negative? Think about it. This radius is positive or negative? It is negative. Very good. My students, my warriors have finally understood it. I am so happy about it. This is positive, this is negative. Put it minus r. Done. So now if you solve this, this is 3 and this is 10. 1.5 minus 1 is 0.5. 0.5 is half. 1 by infinity 0. Minus plus. So 1 by r again. Okay. So just goes there. So 20 by 3 is 1 by r. So r is nothing but 3 by 20, which is 0.15. It's in meters, so this is also in meters. That's it. Done. 0.15 meters. Hey, it is. Sir, it's dinner time. Choti kar do. Chutti. Oh, choti. I'm like, choti kar do. I'm like, choti. Like, really? You guys have long hair? I missed EM waves. I was late to the class. No problem, B. Monica. Guess what? You can watch the replay even after the session is over. Okay? Why was R infinity, Sayyad? Simple, bacha. This is small radius. This is big radius. This even large radius. Flat, infinite radius. That is why this is infinity. Got it, Sayyad? Yes. Oh my god, I loved that dialogue. Anirodhama. Chodi bachi ho kya? Oh my god, that meme and that reel is so trending. Chodi bachi ho kya? Okay, now for those of you who did not get it, it's like, are you really a small kid? It's like that. Okay, don't worry. Those of you who did not get it, it's like trending. You should know that joke. Okay, so moving on. What is the focal length of a convex lens of focal length 30 centimeters in contact with a concave lens of focal length 20 centimeter? It is a system of converging and diverging lens. Is it converging or diverging? Ignore the thickness. Why was R infinity? Janaram, I just explained. Just rewind back the session just few moments before. Why was R negative, Niveta? That is because of sign convention. Whatever direction the rays travel, that is positive. So this is positive side, this is negative side. And Janaram, the moment you make it flat, it becomes very big circle, very huge circle. Think of a flat surface as a very big circle. Radius is infinity. That's why. So wherever light travels, positive. Wherever light is opposite, that's negative. The center of curvature is here. So center is negative side, hence it is minus R. Okay, moving on. So I think we should use the formula 1 by F effective is 1 by F1 plus 1 by F2. If you notice, focal length, convex lens. Convex is positive, so plus 30 plus 1 by concave, diverging, focal length will be minus 20. Those of you who will put plus 20 will definitely get a wrong answer. Yes. So now this will become, take the LCM, it will become how much? 60 and 2 minus 3, this is minus 1 by 60. So effective focal length is minus 60 centimeters. Is it converging or diverging? Is it converging or diverging? Because F is negative, it means it is behaving like a diverging lens. Diverging lens. Ignore the thickness, that's okay. Negative sign, diverging. Very good students. Perfecto. I can see many of you answering it. Guys, I can clearly see many of you are going to get clearly very good marks. I can see this right now. Many of you are going to get very good marks. Trust me on this. Keep attending, revise. There should be nothing which you do not know. Even when you get options, you should not be like, oh, I don't know this option, that's why I'm doing it. It should be like, I know this also, I know this also. I can do both. Let me see, I will do this one because it is going to be shorter. That is how you're going to choose the options. Cengage is not a good book to crack JEE. Sandeep's diary. Sandeep is going to note down my age in his diary. Okay, next question. How when computer engineering needs G? My God, I didn't understand. In a telescope, focal length is this much, eyepiece is this much, magnifying power is how much, tube length is how much. Guys, this is the easiest of all. If you see this question, pounce on it. They might just ask you to draw the diagram if it comes for 3 marks or more. They can ask you, draw the diagram. Okay, that's fine. So use the same diagram which is there in NCRT. That's all. So see, magnifying power is so simple because you know it is ratio of some focal length by some focal length. By chance you forget it in the exam, don't worry. I mean, it will be bigger number by smaller number. You should be really stupid to put it as 5 by 60. 5 by 60 is smaller than 1. So try to make it more than 1, even if you don't remember the formula. But anyways, it is F naught by Fe, so it is 60 by 5, which is 12. And the length is just the addition of the focal lengths. Remember that? So 60 plus 5 is 65. That's it. For this kind of questions, you cannot afford to leave optical instruments. It's like free marks in your pocket. Free marks in your pocket. You cannot leave this. Joy Xavier, yes, bacha, this is there in NEET. This is there in JEE also. Next question. Single surface refraction. Notice the question. Oh my God, Sharan, should I write it slow? Oh, Sharan, Sundar Pichai, the next CEO of Google. Sharan, please don't spy on me, okay? Whatever I talk to Alexa and Google. Answer given is minus 12, is it? Oh, why is it given as minus 12? Why is the answer given as minus 12? Because actually this image is inverted. That's why you add the minus sign. Why is the answer given minus sign? It is because the image finally becomes inverted. That's the only reason. Otherwise, magnitude-wise, it is just 12 times. But because of the inversion, you will see the minus. That's all. Yes, you can put minus sign in the formula. That minus sign is just to tell you the image is inverted, nothing else. IPC does not have negative focal length. Don't think like that. See, even if you go back to this formula, where is it? Here. Yeah. So this is just giving you the magnitude. Think of it. But actually speaking, it will be negative because of the inversion. That's all. Because of the inversion. You can see the ray diagram also. Just look at this ray diagram. Look over here. The image is inverted. Do you see that? Right over here. The image is inverted. Same thing is there even for, where is that? Your compound microscope. Where is it? Compound microscope. Yeah, look at this. The image is finally inverted. Look at this. This is the object, this is the image. It's finally inverted. Everything will come out to be inverted. But what about simple microscope? Is the image in a simple microscope erect or inverted? Come on, answer this. $1 million question. But I don't have $1 million, so I'm just telling you, chumma. Is a simple microscope image inverted or erect? It is erect, correct. Look at this. It's erect. It's right over here. Okay, a simple microscope. The image is erect. You can see that right over here. Okay, so that's the only one which produces erect image. Rest all will produce inverted image. Okay, very good. Now let's move on. Yeah, so let's solve this. What do we have over here? We have single surface curved refraction. So this is my curved surface. This is my radius. This is my radius. Okay, this is my object. This is my object. This is my image. Rays are going like this. If this is my pole, this is my pole, this side becomes positive, this side becomes negative. The direction in which incident rays goes, that is positive. Okay, so let's start writing down whatever we know. Object distance u. The object is at a distance of 20 centimeters from the round edge. 20 centimeters from the round edge, yes, that is your object distance. So it is minus 20 centimeters. Image distance, I don't know. V is exactly what I don't know. Radius, think about it. Radius, for radius, look at the center. Is the center on the positive side or on the negative side? Pole is always the origin. It's on the positive side, so R has to be plus. Radius, 5 centimeter, so put plus 5 centimeter. Last thing, what is mu1 and what is mu2? Mu1 is where the incident ray is. Mu2 is where the refracted ray is. Incident is in air, so put 1. Refracted is in glass, so put 1.5. Lot of students commit this mistake. They think mu1 is where the object is, mu2 is where the image is. That's completely wrong. That's nonsense. If somebody has told you that, please don't remember. Gauri Shankar, I just taught Cartesian sign convention of refraction for telescope. It's the same thing, bacha. It doesn't change. For everything, it is the same thing. Keep this in mind. Okay. So, no, it's not like that. Mu1 is for incident, mu2 is for refracted. Keep this in mind. Okay. Now I know what to do. Mu1, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Substitute everything and you shall get the answer. Everything you know, this 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 you know. V, I don't know. Solve it, you will get the answer. Everybody can do this. Come on, quickly do this and tell me how much is this. It is 30 centimeters, yes or no? Just check this out. Okay, just look at this. Is it 30? Yep, it should come out to be 30 centimeters. So final value of V should come out to be plus 30. Plus means it is on this side, minus would mean it is on this side. Achha, if I ask you, is this image real or virtual, then what will your answer be? What formula is this? Arvindan, this is the curved surface. If you have one curved surface, then you use this formula. No, it is not 10. Yes, it is real. Yes, it is going to be a real image. Why is it a real image? Because the image is formed on this side, that means the rays will converge to make it. And if V came out to be negative, then it would be a virtual image. No, it will not come out 10, Niveta. We can try it out if you want. It won't. It won't. Just check this out. Mu2 is 1.5 by V. V is how much? I don't know. Mu1 is 1 divided by U, which is minus 20, is equal to 1.5 minus 1 divided by R is 5. So 1.5 is nothing but 3 by 2V minus plus, so 1 by 20, 20 is equal to 1.5 minus 1.5. 0.5 is half into 1 by 5, 1 by 10. Okay, so 3 by 2V is equal to, this goes there, so 1 by 10 minus 1 by 20. So this is 2 minus 1 by 20, which is 1 by 20. Now I can cancel few things like 2 and 2. So V goes on the top, so V will be 3 into 10, which is 30 centimeters. Just check this out. It is 30 centimeters. Okay, moving on to the next question. Okay, no problem. You should understand your mistakes. Don't repeat the mistake in the exam. It's good you made the mistake. I'm so happy. I'm so glad you made the mistake. Because I know now in the exam you'll be extra careful and you will not make it. Maximum magnifying power of a magnifying glass of some focal length is how much? Hi Pi, if you are using Cengage, please give it in Raddi, give it to some Bhangarwala, get some money out of it, buy a new book. Which is that book? H.C. Verma. H.C. Verma Concept 1, H.C. Verma Concept 2, Arihant P.IQ, and one small book if you want to crack GE Advanced, that is Erodo. Nothing more, nothing less. Yes, the minus sign is coming due to sign convention, correct. So guys, max power happens at least distance of distinct vision. है ना? So magnifying power will be 1 plus D by F. 1 plus D, you should know the value, it's 25. Standard human being, average human being. Babies, you know for babies how much it is? 8 centimeters. Now you regret not being a baby. Babies can see clearly till 8 centimeters. As you grow old, that 8 becomes 15, 20, 25. You become more old, 40, more old, 1 meter, few more, then it will become 2-3 meters. You can't see anything here. Yeah, so that's what happens. Your power reduces. So this is 50. So this becomes obviously 1.5. That's the answer. You didn't see magnifying glass. Oh my God. What did you guys see? Okay, Harishma. When to use 1 by V minus 1 by U? I guess Harishma. See, 1 by V minus 1 by U will be used when you know where the object is. You want to find where the image is for a lens, concave, convex. This is magnifying glass, optical instrument. This one, where did it go? This is this optical instrument. This is the formula that you're going to stick. 1 by F. Nah. Where did you guys? Oh my God. You guys are thinking about power. Magnifying power is different from just the power of the lens. Power of the lens is different from magnifying power. Magnifying power, remember, is this one. Where is it gone? Oh my God. Yes, magnifying power. Angle subtended by the object for an unaided eye comes over here. Angle subtended, angle subtended by the aided eye by the image comes over here. This is magnifying power. What is the minimum value? Shri, minimum value is this one, D by F. Guys, now are you seeing why these mock tests are important? Many people ignore boards. Boards, come on, chill macha, I can do this. All these mistakes happen. Be very careful. Now, if these mistakes can happen here, imagine the number of mistakes might happen in your actual JEE and NEET exam. There the concepts are even deeper. So that's why I say, be very careful. Never be overconfident. We are students. I am a teacher. Even me being a teacher, I am never confident. I'll be like, oh my God, something can go wrong. I need to be extra careful. I can do some silly mistake. In spite of being a teacher, I always think that I might learn something. So have that attitude in you. Okay, let's go here. Where are we? Achha, this is done. This is done. Oh, we came to wave optics. We came to wave optics. Yes, just power is different from magnifying power. Ready, guys? Finally, yes. Now, let's have a look at what is there in wave optics chapter. Oops. Okay. Now, many things are deleted again in wave optics. You are the lucky batch, right? Yeah, so make the best use of this. Okay. Light travels in straight line. Definitely you can read this important paragraph. Whatever comes in the blue box or in the summary, basically, very important. Trust me, I won't highlight it. Okay. Now, Huygens principle. What is the meaning of Huygens principle? There are many definitions here. Definition of wavefront, definition of ray, meaning of secondary wavefront, then the meaning of Huygens construction, and also how do you exactly construct it, and then proving refraction and reflection of waves using Huygens principle. All these concepts are very important. Derivation, like I told you, I'll do it later on, day after tomorrow. But today we'll learn to apply and use the concepts. Doppler effect, not there, don't worry, don't bother. Now, coherent and incoherent sources and how they meet and how they create interference and what is their amplitude, what is their intensity, what is their path difference, phase difference, all these concepts are there right over here. Most of it is just formulas and derivations right over here, including the, look at him, he's so young. Yeah, so he was very young, 1773 to 1829. Yeah, so Thomas Young, he was the guy who proved Newton wrong, but Newton and his associates never believed him because for them their theory was more important. So he was the guy who proved that light is actually a wave and not a particle. And this is his famous experiment called as the Young's double slit experiment. And you can see the beautiful patterns formed because of interference right over here. And we're going to see all of this right now. Okay, so let's go directly to the theory part. It's a chill chap. Okay, it's a chill chap. Okay, so where do we start from? It's a very small thing, guys. Let's do this quickly and then we can have dinner, everything. Even I'm hungry, very hungry, very super duper hungry. Already have, you want 2 minutes break? Okay, we'll take a 2 minutes break if you want. Just 2 minutes break, quickly we'll return. Hello guys, I'm back. So just had my dinner. I hope you guys too had your dinner as well. Yes, Doppler effect deleted. Yes, it is. We are back. Yeah. So we're all fine now. Okay. All no problems. Ridhishri always there for you guys. Sanjit had his dinner. Sabri also had his dinner. Yes, very good. You guys are very quick, just like me. Just like I had my dinner. I had some nice air, and my gravy was water. It was so good, so yummy, guys. 2 minutes making Maggie, guys. It's marketing gimmicks, Karthik. 2 minutes. Which Maggie has ever been cooked in 2 minutes? I've never seen. Okay, so let's do this. Okay, guys. I just told you, Pakinanthan, 1972. Pakinanthan, why your name has 1972, man? You are that old. Or is something happened 1972? 3 minutes approx. Maggie is a lady. Oh, that's trivia for me, general knowledge. Nice. Okay, let's go to Huygens. What did this guy say? This dude said that light is a wave and light is not any ordinary wave. My God, this is so confusing. Just some time back, we started the chapter by saying, the session saying, light is an electromagnetic wave. Now, this dude over here, 300 years back, 200 or 300 years back, he told light is a mechanical wave. Mechanical wave. So, Huygens said light is a mechanical wave. But is it correct? No. Light is a mechanical wave. And it travels in some medium called as ether, which nobody could find. So chill that time was. You just confuse people. You just need to be a little bit famous, need to know a little bit high funda stuff, and you just need to make something really cool theory. That's it. You can just play around with people's minds. How evil can you be? You just say light is a mechanical wave and light travels in a medium called as ether. People dedicated their lives to find where is this medium? Where is this ether? What is this ether? Nobody could find 100, 200, 300 years. And later on, Einstein, Hertz, all these people found out that light travels with the same speed. It does not need medium. And Maxwell told light is an electromagnetic wave. Everybody was like, really? All this while, you just played around with us? Crazy. Yeah, but I mean, now we are joking about it, but think about it. During that time, to imagine this is very crazy. Yeah, now it's easy for us to laugh about it. Okay, let's move on. Now, whenever we talk about a source, of anything, any wave, by the way, Huygens is applicable for even sound, any kind of wave. So, a source is nothing but a creator of disturbance. It disturbs. Like when you drop a stone in water, it disturbs the water. It creates water waves. When you pull a string, you are creating a disturbance. Your hand is the source of that wave on that string. When I'm talking, my vocal cords vibrate. That is the source of sound. And then what you will see is the disturbance propagates, travels. There is a direction of propagation of the energy. That is basically called as the ray of light, direction in which the energy moves. And if you draw a perpendicular to all of that, that is called as a wavefront. Reason, all the points on a wavefront oscillate, get disturbed, move together in sync, in harmony. They are all the points, they are in phase. Meaning, like when you drop a stone in water, the waves propagate, they reach some points together. The disturbance reaches some points together. All those points, you'll see they will go up and down together. They are in sync, in phase. Those collection of points is called as a wavefront. And the shape of the wavefront? The shape of the wavefront depends on the source itself. If the source is weird, you will see the wavefront is also weird. That's how it is. Alright. Now, according to Huygens, what happens is, if let's say there is some wavefront which is like this is some wavefront, random wavefront which I have drawn. He said that every point on that wavefront, every point, this 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 point, so many points. Each point on that wavefront acts like a source which is now called as a secondary source. This was primary, this is secondary source. This is secondary source. Now what does the source do? It creates disturbance. So if you have so many secondary sources, each secondary source creates new disturbance in the direction of the wave propagation. For example, if the ray of light is going like this, the wavefronts are created in the direction of the ray propagation. These wavefronts are called as, because they are created from secondary sources, they are called as secondary wavefronts. Secondary wavefronts. Now, when you draw a common tangent, it gives me the new wavefront. It gives me the new wavefront. That's what he said. This entire process is called as the Huygens construction. It is called as the Huygens construction. It is a new wavefront after time t. After time t, the radius of these circles is ct. What is the radius of these circles? The radius of these circles will be speed of light into the time after which you are drawing it. Travels in all the directions, Sanjit, but he said that you should ignore those wavefronts which are behind. Don't consider that because light is going this way. Only consider those wavefronts which are going ahead. Yes, Anirudh, it will continuously travel. They even say, Anirudh, whatever you speak never actually dies. Think about it. It's got a very deep meaning as well as a physical meaning to it. If I'm talking right now, or even if I drop a stone in the ocean, that energy goes and hits something, but that in turn will affect something. Yes, the energy distributes on a large volume, large surface, so you cannot feel it, but it is there. Energy cannot be created or destroyed. So your voice, whatever you speak, is there. Maybe it is interfering with hundreds of other things, so you cannot actually decipher it, but it is definitely there. Yes, can we say each point on the wavefront acts like a source for its secondary wavelets? Yes, definitely. Is the speed of EM waves in vacuum C? Yes, Karthik, it is. Got it, Anirudh, very good. Now, interference. All right. Now, talking about interference, but before that, talking about sources. Imagine you have a source S1 which is generating a wave like this. You have another source called S2. It is generating a wave like this. You have another source S3 which is generating a wave like this, then like this, and then like this. You have another source S4 which is generating a wave like this. If I ask you, out of these sources, which sources are coherent? Coherent means you know when this source is doing this, the other source is doing that. I know what you are doing together. I know the exact relationship. I know the phase difference. They are not necessarily in phase. They should be. They should just be. By the way, these two are coherent. and coherent means their phase difference should remain constant. When I see that there is a crest, I know there is a trough. So I know for sure if I go to any other crest, I will get a trough. I know that for sure. I don't even have to bother about it. I know when there is a trough here, there is a crest. I go to any other trough, I get a crest here. I know the relationship between them. Wavelength and yes, frequency will remain the same. But these, it's random. Look at this. I mean, like really, it's broken. This is changing frequency, not coherent. And now that we have talked about phase difference and all of that, look at this. If I have one source over here and another source over here, and this generates a wave which reaches here, this generates a wave which reaches here at some point, these two waves are not traveling same distance. So one wave travels more than the other, because of which you will see there will be a difference in their path which is created. Both start, you and your friend start from the house at the same time. You want to reach the school. You stay closer, your friend stays far away. You are walking at the same speed. You will reach first, your friend is still few kilometers away. You both are traveling, you both are starting at the same time, same speed, but there is a difference. That is your path difference. Now, if you notice over here, maybe this is some extra distance. That extra distance is called delta x, which is modulus of S1p minus S2p, which is called as the path difference. This delta x is called as the path difference. Now this and this are related. By the time you reach here, you will notice this guy's crest might be arriving, this guy's crest might be arriving, or the crest from here is arriving, a trough from here is arriving. There is some phase difference between the two waves and it is always maintained. And that relationship is given by a very simple formula. Observe, delta phi is given by 2 pi by lambda into delta x. Standard formula. You should know this. You should know this. Okay? Threshold voltage, Rahul Krishna, is that voltage which you need to supply at least, in that bias, so that the diode starts conducting. Before that, you will not see the diode conducts with great current. Okay. Now, having said that, if these two sources, let's say this is having some amplitude, let me put it over here only, maybe using some different color. This has amplitude A1, this has amplitude A2, this has intensity I1, this has intensity I2. Guess what? When this has amplitude A, this has amplitude A2, when they meet, the resultant wave has a new amplitude, new intensity. And it's very simple. If you draw the amplitudes like vectors, like this is A1, this is A2, this is the angle between them. The angle is the phase difference itself. The phase difference, you shall get the resultant amplitude. Resultant amplitude, vector addition, nothing great, nothing less. Okay, so this AR is basically root of A1 square plus A2 square plus 2A1 A2 cos del phi. Same formula what you learnt back in 11th standard. This is called as superposition. Superposition means you are adding their effects. You are adding their effects and you get a resultant wave. Superimposing, impose one over the other to get the resultant effect. That's what it is. And the intensity, the resultant intensity formula is very similar. Look at this. Resultant intensity is I1 plus I2, no squares, except for the squares, everything is there. And instead you have a root. So 2 times root I1 I2 cos del phi. That's the formula. This is what you can use. Now, Revenant, I'll explain this to you in case you are having a problem. Don't worry, bacha. Okay, look at this. Imagine There is a point here, S1. There is a point here, S2. Example. You are here. This is a point P. Let's say this distance is 6 meters. This distance is 8 meters. Now, the light from here reaches here. Light from here also reaches here. Do you think they will arrive at the same time? Yes or no? Yes or no? Think about it. Obviously not. This will travel more, this will travel less. So if I ask you what is the path difference, what will you say? Bigger length, which is S1P minus S2P. Now by Pythagoras, if this is 6, this is 8, naturally this is 10 meters. So this will be 10 minus 6, which is nothing but 4 meters extra. That is your extra path difference. Got it? Very good. Now if I tell you that the wavelength of S1 and S2, the wavelength of S1 and S2, I don't know, I'll just put it something. Maybe it is 8 meters. Example. It is just like 8 meters, or I can even put some other value, right? It really doesn't matter. Okay, maybe I put it as 16 meters. Doesn't matter, something. Then I ask you, what is the phase difference between them? Then what will you do? All you will do is, you will use the formula. Del phi is 2 pi by lambda into delta x. What is lambda? What is lambda? Lambda is 16. So put 16. Delta x, you just figured it out here. It is 4. So this goes 4 times. This goes 2 times. It is pi by 2. Delta phi is pi by 2. You got it. Now let's say, for example, they tell you amplitude of one, I don't know, maybe something, is 4 meters. And amplitude of 2 is, I don't know, something like 3 meters. Example. Then what is the resultant amplitude? Resultant amplitude. Just look at this. Angle between the two, the phase difference is pi by 2. It's going to be a very easy job. Just draw one vector whose amplitude is 4, another vector at 90 degrees, so whose length is 3. Naturally, this happens to be your resultant. How much will be the resultant? It is just going to be 5, so the resultant will be 5 units. As simple as that. Got it, guys? So this is how the problems are. It's super duper simple, dimple, easy. You should know that the 3 things are just related to each other. Oh, where are we? I think I'm in some, different mode. Let me just remove this. Okay. Cool. Moving ahead. Yes, Young's double slit experiment. Let's come to that. So you have a source. You place a partition with a slit here and here. This distance is small d. You place a screen over here. This is the central point O. This is your distance between the screen and the slit. You will see that the light waves which are generated will pass through the slits, and you will see 2 new sources created right over here, and they will interfere. They will interfere with each other, and if you go to any point, over here which is making some y coordinate y, having some angle theta, you will notice that at that point there is some path difference, that delta x happens to be d sine theta, and because as you change your position, the path difference changes, you will see sometimes it is constructive, sometimes it is destructive. Constructive, destructive. You will notice something like this, a bright fringe here, bright maxima here, then darkness, again bright, and again darkness, again bright, and the same thing continues even below. These are called bright dark fringes. So this is your bright fringe, that is also known as maxima, and maxima happens wherever there is constructive interference. constructive, crest with crest, trough with trough. Whereas these points over here, these are your dark fringes, these are also your minimas. This is where destructive interference happens. Destructive interference happens. Not just that, from one bright to next bright is called as a fringe width. You can also call from one dark to next dark also as the fringe width. It's one and the same thing. And what is the value of the fringe width? It is lambda d by small d. Lambda d by small d. Fringe and fringe width. See, fringe is nothing but bands. Like it's a fringe. Okay, one like the zebra stripes, those are white fringe, dark fringe, white fringe, black fringe. So zebra crossing you would have seen on the road. So that is also fringes. Fringe width means nothing but from one bright to one bright or one dark to one dark. So the width. So between two brights there is a dark, that is the fringe width. Or between two darks there is a bright, that is the fringe width. Understood, bacha, Anirudh? Yes, correcto. Very good. Let's move on. Okay. So having said that, some key pointers in YDSE. Remember, I'll just put it over here. The intensity of all maximas is similar. That means this brightness is same as this brightness, is same as this brightness. It's not like it fades away. It fades, but after a very long time, you need to go really far away. But usually the intensities are roughly same, constant throughout. That is first thing. Young's double slit experiment is because of the interference. Of two waves. Very, very important. Interference of two waves. Waves from here, waves from here. Two slits. The next experiment that you have is single slit diffraction. Meaning, you just take a slit here. Of width A. And you place a screen. You will notice that there is interference happening just like before. You will see a bright region here, dark, bright but not so bright, dark, not so bright but bright, dark, bright, not so bright as this one, dark, not so bright. You will see that the first thing that you will notice is that interference pattern is obtained even with a single slit, but the maximas fade away, or basically you can see the intensity lowers as you move away from the center or the central maxima at the center. And the most important thing is the interference happens. Like, sir, how can interference happen? I'll tell you where the interference happens. Basically, there are many sources here. This one. So many wavefronts. Basically, there will be so many rays of light which will be interfering at a point. So it is not because of interference of two waves, just like it happened in YDSE. In case of single slit diffraction, it is because of interference of many sources within that slit. That causes the interference. Do you guys get the difference? Yes, they can ask you to define interference. Yep. For YDSE also I did one slit. Very important, very interesting observation. So actually, you know what happens in YDSE? You get superposition of single slit and a double slit. It's a combination. It's a combination of both. Oh my God. Yes. So in YDSE, you get single slit diffraction, and the regular double slit interference. So when we discuss YDSE setup, we are generally not bothered about the single slit diffraction effects. Derivations day after tomorrow, Sandeep's diary. Okay, now last pointer over here which you should know is for bright and dark regions. So the angular position theta for maxima is lambda by a, and theta for minima is odd lambda by a by 2. This is the difference. So wherever you got maxima, the angular position is lambda by, wherever you got minima, it is odd by 2 lambda by. That is the difference. Yeah, if you look at the graph for diffraction, it will look something like this. If you draw the graph for intensity, so it will first be very tall, then it goes down, fades away like this for diffraction. But for Young's double slit, it will be constant. You will see the intensity is maximum, then drops down, maximum, then drops down. This is how it looks like. Okay, Lakshmi Kumar, shall we do some questions? Last set of questions, guys. Ready, set, go. Can white light produce interference? Let's say Young's double slit interference. And how do you think will be the nature? How do you find the width of the central maximum? Johan, it's simple. See, central maximum is between, where is it? Is between this and this. You find the minima, first minima. You find the first minima. Look at this. You find the first minima. It will be the same thing here. So the double of that will be the width of the central maxima. That's it. That's how you find it. Simple? Okay. Let's see the answer to this question. If you use white light is made up of many colors. Violet, indigo, blue, green, yellow, orange, red. Violet will interfere, red will also interfere, but it is only at the center. It is only at the center will all come together because at the center you always get a maxima, but the fringe width depends on the wavelength, meaning each color will have different fringe width. So violet will having different fringe width, red has different fringe width, yellow different, green different. It will all get mixed up as you go away over here. Only at the center all the colors recombine together. That's why you will get white color at the center, but everywhere else it will be a complete mixture of all the colors. There will be no regular pattern. Yes, it will be very colorful in nature though. No, it will not look like a rainbow, but yeah, it looks colorful like some shade, like some gradient, like those gradients. That's all. Yep, few colored parts. Next question. In Young's double slit experiment, the distance between the slit is halved. What is the change in the fringe width that will take place? Come on, my warriors. This is so simple. Everybody should spam and answer this. Everybody should spam and answer this. Come on, my warriors. Gradient. Do you see the color of this text box or the color of this box? Do you see it is different? Here it is more purplish, here it is more violetish. That's a gradient. Imagine pink, then suddenly it becomes blue, then green. It's a gradient, slow, natural change of colors. I hope that makes sense. Supriyadi. The answer is it doubles, and the reason is beta is lambda d by d. How? D has become half, 2 goes on the top, so beta will become twice. Simple. Done. Moving on to the next one. This is going to be a very tricky one. I'll tell you why in a bit. In a double slit experiment, wavelength is given, angular width of a fringe is 0.1 degrees. What is the spacing between the two slits? Understand the question first. You have a double slit experiment, S1, S2. This is your screen. Okay, this is your origin. Obviously, there will be bright and dark fringes. One such fringe is taken. This is from this one bright to the next bright. Obviously, this is your fringe width. The question is, this angle is given to be some 0.1 degrees, and let's say I'll just call it as theta for now. I think this beta and theta are related. I'll tell you how. This distance is d, and I know one thing. If I take an arc, the length of that arc, if this is theta, this is radius, is r into theta. So using the same concept, this is like a small angle, this is like almost like an arc. This is d, the radius is also roughly d because these angles are not large enough. So can I not say beta, which is the length of the arc, is radius in this case, which is d, into that theta? Makes sense? Okay, now let's solve this question. What is beta? Beta is lambda d by d. This is d, and theta, dd goes. I think we need to find small d. So small d will be, lambda by theta. That's it. So we solved it, we reduced it. Last step, substitution. Lambda is 600 nanometers. So 600 nano, 10 to the power minus 9 divided by theta. What is theta? It's given 0.1 degrees. Now if you put 0.1, you will lose all the marks because this is in degrees. You should never put it in degrees, put it in radians. So multiplied by pi by 180. This is the tricky part of that problem. Be careful. Okay, so convert it into radians. Very good, Anirudh, Zaid, Karthik, Samir, excellent, Sabri. Now solve it and you shall get the answer close to 3.44 into 10 to the power minus 4 meter. That is a calculative part, something which you can do, but this is the catch, trick in the question. Perfecto. Let's move on to the next question. Sir, pi by 180, oh come on. You are guys in 12th, now you are asking me this. Okay, chalo, I'll tell you how to do this. You want to convert, see, I'll tell you, simple way, simple. You want to convert from degree to radian? Radian you want to get? Radian means pi. So pi should be on the top. You want radian, no? So pi should be on the top. Pi radian, and this is degree. So multiplying that degree into this will give you final in radian. Number one. You have it in radian, you convert it into degree. So get the degrees on the top. Radian, put it below. So your radian into this gives you your degree. That's all. You can see radian cancels. You can think of it that way also. Radian cancels, gives you degree. Degree cancels, gives you radian. Now you'll never get confused. Got it, bacha? Simple? Okay. No problems. Happens. It's good you asked it. So that now you will not make that mistake. I'm so happy you guys asked it. Okay. Samir, using log tables is a whole big deal in itself. Maybe I should conduct a special class for that itself. In a double slit experiment, instead of taking slits of equal widths, one slit made twice as wide as the other, then the interference pattern will be, this pi radian is 180 degree, correct. Vijayalakshmi will not be able to find the Telegram channel. It's a private channel. You have to go to the description box and then click the link and then join it. Only invitation via the link, no other way. Now, usually what happens whenever there is a bright region and when we have a dark region, usually what used to happen, you had one wave, other wave, giving rise to one big wave. In the dark region, this wave destructively interferes to give nothing. This is what happened in your normal YDAC setup. But if you make one slit wide, that will have more intense light. More intense light means more amplitude. So one of the wave will be larger, other wave will be as usual. This will give me a very tall wave. So the bright becomes brighter. Bright becomes brighter. Did you just see that? The brightness increased because one of the slit was increased in its width, more light, more amplitude, more intensity. And for the dark one big wave destructively interfering with this will not cancel completely, so I shall get a slight a slight amplitude. This is not completely dark, it's a dim light. So the dark becomes brighter, bright becomes brighter. There is only one option like that. There you go. And guys, log table not required anymore. Yes, for most of the questions you will not need it. What is the name of the I can't join. No, Vijay Lakshmi, I'll tell you. In that link, it might have something like this, t.me/ I don't know, something like this. So replace this T with the word Telegram. That is the hack that you need to use. Then you will be able to join it. Just try this out. So guys, what happened in the previous question is, when equal widths are there, you can see amplitudes are also equal. Constructive, A plus A gives 2A, A minus A gives 0. Now, when one width is made twice, so it will no longer be A plus A, it will be A plus 2A. A plus 2A will give me 3A, and 2A minus A will give me A. So what has happened is that earlier, wherever you are getting perfect destructive, you will no longer get destructive interference because the amplitudes are not equal. One of them has been increased. So you will get, instead of dark region, you will get a dim grayish region. And wherever it was bright, it will become even more bright because you have increased the width. Got it? Okay. Yes, t.me sort of links are blocked in India. That's the issue. Correct, Gem Gamers. Wow. Moving on to the next one. When a thin metal plate is placed in the path of one of the interfering light beams of a YDSX setup, what do you think will happen? Sabari Srinivasa, when the path difference exceeds by lambda by 3, it is then going to be a intermediate interference. Sarika, my 2x speed is fine. You mean, am I speaking slow or am I going too fast? Disappear? Yes. What happens is, if you have two slits like this, if you cover, how will the rays interfere even? No interference, gone, done. Gone, no interference. You need two waves. Oh, I'm going slow. I'll tell you why I'm going slow, because I just conducted almost a 3-hour class on another channel. Now conducting another class for 3 hours, it's consuming, it's straining on my throat. So that's why I'm talking very slowly, guys, today. Okay, so you can watch the recording at 2x speed. I don't mind. Okay, I can't talk faster than this. My throat will go. I have to conduct 2 more classes tomorrow, and 2 more classes tomorrow, and 2 more classes tomorrow on YouTube. And YouTube is more strenuous than anything else. I mean, like, if you take a normal class, offline class, when I used to take offline classes, it was very cool, like chill. The moment you come into online, I need to keep talking, or else you'll be like, why is he silent? Is the video stuck or what? Let me press something. Oh, he's not talking. Let me just go to the next video. Just switch the channel. It's so crazy. Okay, moving on to the next one. Which one of the following property of light does not support wave theory of light? Okay. Yeah, after this I'm going to have water and I'm going to have food. Yes. My body is tired, and morning I'm going to wake up at 6 o'clock and then I'm going to hit the workout. I'm going to go for my, my regular body workout. Yeah, 6:30 in the morning. Won't it become? Yes, it becomes single slit, but in that single slit, you do not know what can happen. It could be bigger, brighter fringe, darker fringe, whether it becomes larger, whether it becomes smaller, we don't know. Slit width is not given, wavelength is not given, hence you cannot comment about the single slit. No, I didn't have my dinner, Sarika, yet. No, I don't go cycling, I go for weightlifting, I go for exercises, dance, all that. Yeah, so basically it's a workout station. We all go together. Yeah. Yes. So let's see. Yep. So light shows photoelectric effect. That's the answer. Very good. Photons show particle nature. Everything else, light waves get polarization. Polarization is a wave characteristic. Huygens principle can be used to prove reflection and refraction. Huygens is a wave theory. Light shows interference. Interference, naturally, it's a wave theory. Only photoelectric effect is a photons particle. Hence, how to remove root of a significant figure in dual nature we used to. Samir, I had made a video on how to find square roots. Just watch it. Just search for Shreyas sir square root. You will get that video. Very easy on YouTube. And the best thing about YouTube, imagine studying all my classes on YouTube for free and supporting it with the crash course, assignments, systematic study. You get your assignments, you get your test series, and you get my lectures. I'm also teaching in the crash course. JEE people know that already. You have crash course for NEET as well. The best part, both the crash courses are priced the same way, 2,700 bucks. NEET students get physics, chemistry, bio. JEE students will get physics, chemistry, maths. NEET students will have your regular assignments on NEET. JEE students will get based on the JEE pattern. Same thing for test series, for all India rank, everything separate. And the batch has started already, but you can watch the recordings. Make use of the recordings till the last day of the exam. In spite of it getting postponed, you don't have to really worry about it. The link is there in the description box below. Go ahead, check it out. Don't delay the purchase, because I would really like you to use the combination of both the two together. Thank you very much for joining in. Matesh, I think you are asking it a little bit too late. You are already a JEE Pro student, Mr. Zug, then you don't need it. You are already, revisions are going on. Okay, so glad, Anirudh, you had fun. Hello, Vinay. Okay, don't spam, bacha. I took your name. Bye-bye, Revenant. I was listening to your AI live class, freaked out for a moment, and then realized, what happens, BTS Army. Bye-bye, Karthik. Bye-bye, Vinay. Bye-bye, Nandu. And do not forget to leave comments, and do not forget to like, share, subscribe to the channel in case you haven't done that yet. I'll be seeing you guys tomorrow for modern physics, dual nature of matter, atoms and nuclei, of course. And we will have a great session, of course, again tomorrow. I want you guys to get full marks. There is no compromise on this, okay? So don't feel demotivated. Just ping me in case you are, or leave a comment below. I'll definitely reply to it. Bye-bye. Take care. Have a great time. Sleep well. Have a great dinner. This is Shreyas here, signing off. Hasta la vista.